So hello everyone, welcome to today's technical webinar on standard data center connections. My name is Yann Guégan. I'm a senior structural engineer with IDEA US, and I'm excited to be hosting you today for our webinar, our first webinar of the year. With me today, I have Johan Losada. He is one of our product engineers, and I'm sure many of you have been working with them on some of your technical questions in the past. So, most steel projects rely on standard and repeatable connections, not only the complex ones. And the real challenge for these projects are going to be volume, repetition, and reporting, and especially on data center projects. This is where we believe that IDEA StatiCa can help engineers save time from design through the deliverable. So today's focus will be to show you how to work smarter with standard connections using real data center examples. All right. For our summary today, we'll start with a quick summary of IDEA StatiCa's capabilities, and that will be followed by an overview of the standard connections that are commonly used in data center projects. And then we'll start our recorded technical demo, and that will show you batch design, grouping of connections for these high volume connections, along with showing how to build reusable connections. And finally, we'll end with the audience Q&A. All right, what is IDEA StatiCa? I'm sure many of you are new to the software, and I would like to start with a quick overview of the software capabilities across both the steel and the concrete modules. So first, if we look at the steel applications, we'll have the connection application. That's the one that most of you are probably familiar with. Based on finite element analysis, that gives you access to a tool that allows you to do as complex connections as you want. No matter their complexity, you'll be able to model them in our software. We also have the member application that will allow you to model a small frame and look at local stability related questions. On the concrete side, that module is called detail, and we have the first component of detail that would be to allow for concrete member designs, could be beams, core bolts, walls, deep beams, beams with openings. You do have that flexibility in there as well. And finally, we have our detail 3D module, which integrates with the steel connection application. And this allows you to bring base plate or embed plate connections from the steel application into the concrete application to be able to design your anchoring reinforcements in there. And again, any kind of geometry. We're showing here rectangular pier, but it could be a pedestal, it could be a circular pier. Anything could work. And with this, Johan, I'll let you get started, and I'll get back to you later on.
All right, thank you, Jan. So before we go ahead and talk about the different connections that are typically seen in data centers, let's go ahead and get a quick background about these structures. So when we're talking about data center structures, these are not your typical commercial buildings. Instead, these data centers behave more like industrial facilities. So they're unique in the sense that their critical components are the server racks, their cooling systems, their electrical and power equipment. And this is where the uptime drives almost every single decision in the design process. Here in these facilities or structures, the goal is not occupancy. Here, basically, it's to keep this facility operating continuously 24/7 without any downtime. Because here in these facilities, any downtime will have not only operational, but also financial consequences. So if you think about it, not only is the business in the data center affected, but also the businesses that rely on the data centers and the service that they provide for them. So if there's any downtime within those data centers, the other businesses that are relying on those data centers or those data, they will be affected as well. And that is why, because those changing priorities, they will create unique structural and connection challenges. So now here, the focus will shift from conventional loadings to high concentrated loads and even different serviceability limits. As you may know, data centers demand large open spans to be able to allow flexible layouts for their server racks or even their MEP integration systems, such as your ducts, piping, mechanical equipment, all of them competing for space. And from a construction point of view, this is where planning really matters. Being able to have that early coordination between your structural, mechanical, and electrical teams can lead to fewer RFIs or even late stage fixes that might have been overlooked throughout the project. Using precast systems, pre-manufactured buildings, and modular construction approaches are commonly used here in data centers, specifically because they reduce the delays on such fast-track projects. We have also seen that repurposing of existing buildings is increasingly common due to the demand and schedule pressure that these businesses face. This method, however, will require extensive knowledge in the existing load paths to be able to reuse that building correctly. Now, with this context, let's go ahead and look at some of the most common type of connections that we see in data centers. All right, now, take in mind, all of these connections are available in IDEA StatiCa. They can be modeled and analyzed. So the most common, your bolted steel-to-steel connections. These are widely used due to their ease of fabrication and installation, and they make ideal candidates for their standardization and reusability across many different projects. Your steel-to-concrete connections, these include your embed plates that are attaching to the precast walls or pin base plates that are attaching to existing foundations. Although they're often repeated across foundations, equipment loads, and structural frames. The standard modular connections, these are typical for speed and to be able to reduce complexity in the projects. Although they're frequently standardized, they still require verification and reporting. The last one of the main connection types that we have are roof and joist connections, mainly your bolted joist and overhead connections. These are typically repeated across large floor areas. And with IDEA StatiCa, these connections are where time savings really add up quickly whenever you're combining both batch design and the reusable templates that you're able to create in IDEA StatiCa, which is what we will be showing you today in our demo later on in the webinar. But for now, let's go ahead and take a look at each and every single type of these connections in more detail. All right, so the bolted connections here, they're able to reduce on-site installation time by being able to reduce additional steps, such as field welding or extensive detailing that has to be done for those connections, which in turn helps to keep fast-track projects on schedule. Data centers are also built in phases, so these bolted connections allow the expansion of new areas to be added without redesigning from scratch. And since late changes to rack layouts, MEP routings, or equipment loads can sometimes be common, bolted connections provide that flexibility to accommodate those changes without delaying your construction. The steel-to-concrete connections are just as important, and when reusing existing foundations, post-install anchors allowed engineers to help move the project a lot faster and reduce the cost for creating a new foundation. These connections are also often integrated with your pre-engineered building structures or your precast walls for speed and reliability. Now, these typical embed plates, headed studs, post-install anchors are all possible in IDEA StatiCa. Now, one important aspect of data centers is vibration control. Here, connection stiffness and detailing of the base plates directly affect that vibration performance, which is basically very critical for those sensitive IT equipments or those server equipments that are housed in the data centers. So being able to model, analyze these connections with their real stiffness and their realistic behavior can greatly benefit the results. Now, as mentioned, standard and modular connections are all about speed. So with more standard connections, the project will have fewer unique details, which will lead to faster modeling, checking, and approval. Now, your modular connection libraries, they will support rapid expansion across multiple buildings or different phases of that same building. They also allow users to take on new projects that can build on verified details rather than starting from scratch on brand new details. Lastly, having your library readily available minimizes the dependency that you will have on those custom or one-off connections, which in turn, again, improves that consistency and reduce errors across not only the projects, but across the different teams that you have to work with. And last but not least, and often overlooked, but also just as important, are the roof and joist connections. These are used extensively for not only the roof support, but also supporting ductwork, cable trays, piping, and mechanical equipment that are all seen in data centers. Although often repeated across large roof areas and service corridor to be able to help with those large span designs and protect the sensitive equipment that is housed in there. Now, these joist connections or these joist members are often prefabricated, which will in turn improve the quality control and consistency across your project. Now, if we get into the bolted connections of those joist to column or joist to beam, these will allow rapid installation and easier coordination on the field to help you reduce additional steps such as, again, field welds or inspections that might be required for the welds. So now that we covered the different types of connections or the main type of connections, one of the common themes that we see here is speed, flexibility, and reliability. Data centers demand structures that can be built fast, expanded easily, and adapted without disrupting operations. And that's why connection design plays a huge role in making all of this possible. And that's why IDEA StatiCa comes into play. We'll quickly show you here in a few how you can quickly model, save, and reuse your connections across different projects, from modeling, designing, to printing out your report for all the different connections. Before we show you that quick demo, let's go ahead and turn to Jan for one of the poll questions that we'll have, just to get a better sense of our audience.
Perfect. I'll let you launch the poll. If I'm not mistaken, the poll should be, yes. What types of projects are you currently designing most often? So we'd like to know how often you may be working on different industries. That'll be very interesting for us to understand whether these repeatable connections is something that you face very often or not.
All right, looks like we have about 70% of our attendees answered, so let's go ahead and take a look at our poll.
All right, well, surprisingly, actually, data centers only 18%. Industrial, that I'm not very surprised by this answer. But it's very interesting to see that mix of projects, including the infrastructure, so bridges, transportation. That's really nice to see all this. That's very good information for us. On all of these projects, I would say that the capability to do batch design and reuse all connection projects is definitely a key aspect of connection design. So no matter which industry you're focused on, I think today's presentation will be valuable too. Thanks, Johan.
In this video, I'll show you the process to build your own steel connection library in the standalone version of IDEA StatiCa. Later, you can open a connection from your library in the connection wizard. For this example, I'm going to use the file uploaded in the following blog post, where we put together 30 common connections for data center structures. The connection file is available to download it from this link. Once you download it, you can open this connection file and you can start exploring the multiple connections that we save on that file using this drop-down menu. Also, you can go to the Project tab and navigate through them in this list. Now, review the connections and adjust the details to match your standard connection configuration. Once you're good with the details, let's start publishing the connections to the connection library. To do that, you can click over the publish icon here. Publish a connection means that you'll save this connection into the connection library. Let's fill in all the properties of this connection. You can use the names to standardize your library because later you can filter them by name in the wizard. You can also use the load filters to indicate what type of load the design can handle. Like in this case, I'm going to select moment and shear. Finally, you can define where to save this connection, either in your personal or company design library. So the personal means that this connection will be available only in your session, okay? And then the company library means that this connection will be available for all the users that are in the same license pool as you. I'm going to pick personal for now and then hit publish. Once the process is finished, this window will close. Now, we can review the connections that you have saved in your connection library by clicking over the Manage option. You will see how this connection is located here. Okay, you can filter the connections by the different libraries that we mentioned before. You can scroll down and see all the connections. Also, if you click on connections, you will see more details in this area. You can repeat the process as is needed. For instance, in this case, I saved some of the connections from this connection file. We can review them under the Manage option, and you will see some connections from this file. And then I use a specific naming convention for these connections. So later I can identify them. From this connection library manager, you also can delete connections if you by mistake repeated some of the connections or you just simply don't want them in your library. Now that you save some connections in the connection library, you can open these connections from the connection wizard. I'm going to open IDEA StatiCa connection application, and I am going to select this connection icon from the launcher of IDEA StatiCa. After that, the wizard will be open. Okay, so you can start defining geometry and then selecting the design from these libraries. The predefined is an IDEA StatiCa predefined library, and then company and personal, those are the connection library that we talked about before, right? So also you can scroll down and select the all geometries option. I'm going to uncheck the predefined, and then here you will see all the connections from your library. You can also use the search box to filter the different connections that you want to find. Remember that I use a specific naming convention for this connection, so I call them DT. So I'm filter them here, and then we can start a file from these connections. Now, let's review what is the process from beginning to deliverables for a data center steel connection design project. We'll start by adding all the necessary connections for the project. Let's think I need to design the following set of connections. Once I have my required connections in this list, I'll go ahead and look for them on the existing database that I created and pull them in the file. You can use the geometry filters that we have in the connection wizard and also uncheck the predefined IDEA StatiCa database and then look for connections only in your company or personal connection library. You pick the connection you need, you name it, and then you create that selected design. Once you have it there, you can start adding more items in this project file. And you repeat the process until you have the connections that you need, Like in this case, we'll add 10 connections in this file. There will be some connections that we don't have in our library. Like in this case, I'm looking for two beams, two Y-flange beams connected to an HSS column. So what we can do to avoid starting from scratch? Well, in that case, we can go to the web connection library and start looking for the connection. First, you need to define the geometry of the connection that you're looking for. After you define the geometry, you click on Search. Then you can filter by design code. You can scroll down until you find the connection that you need. You click on that connection and then open that connection in the desktop application. Now you can save this connection in your connection library by clicking in the Publish button. Once you publish it, you close this connection. Then go back to your file and select the connection that you just saved. Now that we have the 10 connections from the list, we can go to the Project tab, and from here we can manage the project items. You can rename the connections from this tab. You can put a description. You can also select the analysis type that you will do for the connections. So in this case, I'm going to select a stress strain analysis, but remember that we have other type of analysis. You can also select what connections we'll be running buckling analysis. Also, you can delete or copy connections from this tab. Finally, you can also change the name, number, author, or description of the entire project. The main goal of creating your connection library is to reuse the connection design, but you never have the same cross-sections or loads, so we need to customize them. So for this first part, let's go ahead and change the cross-sections. So in this case, if we click over the cross-section over this bracing element, we can see that this is an 8x8. If we want to change the cross-section size only, we can use the pencil icon here. We click over them. Then we can use these arrows to access to the HSS database. Here I am selecting AISC database. And then I can type the size of the cross-section that I'm looking for. I hit OK, and then later OK again. I'm going to reuse the same cross-section that I selected for the bracing here below. So I click on it, and then I can use the drop-down menu to reuse the section that I just selected. Now, if we need to change the cross-section type, We can also click over the members, and then we can use the plus icon. From here, you can select the cross section that you need for that bracing. For instance, you have an option to select an angle section. These are the common roll sections. You can also come here into welded or built-up sections to pick, for instance, double angle if you need so. So there are multiple options to pick from. So I'm going to cancel this because I don't want to change the cross section type. You can also modify the rotation of the members. The design of this connection was for this bracing to be at 45 degrees, so I can change this rotation by changing the pitch angle. We have other different orientation angles in this area, but in this case, I'm just changing the pitch angle. To guide you on these angles, I'm going to show you this reference that I have here. So these angles are related to the global axis, and the global axis can be referenced using the cube that we have in the main modeling area. The beta angle will be the horizontal, in the horizontal plane. The pitch angle, as you saw, it's the one related to the vertical plane. And then we also have the rotation of the members in their local axis, in their x local axis. Okay, so let's go back to the connection. And then also from this section, from the member setup, you can add offsets that will help you to move a member from the working point. To review what is a working point, you can always go to this view here, and then you will see the working point. So you can use the offsets to move members, and these offsets are related to the local axis of the members. So we can look at the local axis by activating this label. Now let's jump into the connection model changes. Each connection component is modeled by operations listed here. You can click on the connection model in the modeling area, and that will lead you to the operation where you can modify the parameters for that element. For instance, here I am selecting connection gusset 1, and then you can change the parameters from here. You can navigate through the operations from the list or from the modeling area and then adjust the details as needed. You can multi-select similar operations and change the values. For instance, if I multi-select these two gusset plates, I can press Ctrl and multi-select operations, and then I can modify the welds for both operations at the same time. Also, if there is an operation that you don't really need or you are not sure if you need it, like in this case, the stiffener operation, you can just uncheck that operation, and then the stiffeners are gone. If you need to specify a different detail, for instance, if we want to change the connection from this gusset plate to the main beam, instead of welded, I want to change it to clip angle, I can just go ahead and use a new operation. You can click over the new operation, and then you can pick from this table the operation that you want to add into the model. Like in this case, I'm going to use the clip angle. Hovering the mouse over the operations will tell you what operation you are going to select. I'm going to hit clip angle, and that clip angle can be added to a gusset plate. For instance, I'm going to add it to gusset 1. That is a plate element, gusset 1, and that will be connected to member M45. But that will be connected to the web of M45. So you can see the clip angle there. We can pick from welded or bolted connection, and there are multiple options within this operation. I can go ahead and copy this clip angle operation, and assign it to Gusset 2. Now, this is a new design, new connection design that can also be published, so you'll have a different type of connection in your connection library. Now, let's talk about the load setup in IDEA StatiCa connection. The way we are loading to this model is by these load effects. So the load effects are equivalent to your load combinations. So you can add multiple load combinations into this model by clicking over this icon, and then new load cases will be added, right? So you can assess a connection for multiple load combinations. Then once you add a load effect into this list, you will see all the members listed in this table, and then you can add the end reactions for that member. For instance, for member B, we have a shear force, a negative shear force, and then a moment, right? You can add axial forces, shear force in Y and Z local axis of the member, and then moment forces around the local axis of this member. Remember that you can activate this local axis from this icon. You can use negative values and then see, here you can see the direction of that force by looking at these arrows. But remember that this is only a representation of the forces. These forces are applied wherever you tell the software. So if you click over the member B, you will see that we have here an input that's called forces in. That will indicate this to the software where you want to locate the loads for that member. In this case, they are located at the node. So we can look at the wireframe view, and then you will see the loading effect there on the node. The boundary conditions that you should be aware is forces in, as I mentioned, model type that will tell the software what are the degrees of freedom that that member will have. You can fix some degrees of freedom from that input. And then the third boundary condition is the bearing member. You need to select which is going to be your bearing member. In this case, it's a column, so you can see the support area. In our website, you can learn more about these boundary conditions. My final suggestion in this modeling part is to create section views in every connecting element. Section views are sketches that will be available in the report part. So to create them, you can right-click over this plate, and then you can hit Create Section. I already have some sections, so you can click over this section view, and then you'll see all the available sections that I created before. So you can click on them, and then if you think you have a lot of information, you can just click over here and then activate and deactivate some values that you don't need, right? Or you can just delete the section and then recreate it. You can navigate through all these different cross sections that I created. After you review all the connections, you modify the needed parameters like sections, section sizes, connection details, loading conditions, and then boundary conditions. Then we can go ahead and calculate the connections. One option is to go one by one and then click over the calculate button. That will run the analysis only for this connection. The other option is to go back to the project tab and then hit calculate all. That will run the analysis for all the connections that you have in this file. Once the analysis is finished, you can go back to the main modeling area, and then you will see a summary of the results for each connection in this area. You can navigate through the different connections and see the results. Or another way to see a summary of all the connections results, you can go to the report, and then you can select brief, You can select all the items in this report and then generate. In this brief report, you will see what are the connections that were complying with all the checks. Connection 3, it's not okay for the bolts. Connection 4, we have some detailing warnings. Base plate, we have some anchor failing. And then you can have a summary of results and then go back to the design tab and see what are the connections that are not okay. So I go back to the design tab and then I can start reviewing this connection under the check tab. This is a demonstration of the software, but I suggest looking at the results for all the connections you have in this file. Here, I'm going to show you how to review the results with this example. Now, with this summary and then with this traffic color system, this can give you an overview of what's going on with the connection. Of course, the red elements here means that they are failing. You can see this utilization ratio, it's more than 100% for those bolts. The green color means that element or that plate is between 65 and 95% of utilization. The yellow color means it's near the failure criteria, okay? But to have a comprehensive review of results, you need to go to the check tab. In the check tab, you'll have more numerical results, and then you'll have this equivalent stress view or plastic stress view. This is my first suggestion, to look always at the deformed shape and activate the equivalent stresses view, right? Because this can tell you if your model was well connected, if you don't have anything flying out, right? So this is your first sanity check that the model was okay. Then everything, like in this case, everything is connected, but you have some overstress plates, like the shear tabs and the web of this beam. This also can help you to understand the load path of these effects that you model and how the load is traveling to the different elements in this connection. Okay, so this is very helpful to assess if you need to optimize the connection or you need to reinforce the connection, right? We can look at the maximum equivalent stresses in this plates tab, and then you can click over this cell and they'll order these values by the maximums. Like in this case, the maximum, the plate that is the most stress plate in this model is this M2 Web 1. So you will see the plate in this tab, isolated from the model. Then you can keep clicking on the different plates. You can see what was the grade that was used, and then the thickness of that plate, and what was the critical load condition. In this case, we just have one load condition for that connection, right? Then to review the results of the failing bolts, we can go to the bolts tab, and then you can order these bolts by utilization, B9, B8, 7, 6, 5, and 4. They are above 100% of utilization, okay? Once you click on them, you will see them also here, and then you can activate the bolt forces reactions to see the shear force reaction and then the tension force in this graphical area, right? You can always click over the plus icon and then see the AISC checks that we are doing. Remember that we are getting the results from the FEA, and then we are comparing those values versus AISC tension resistant check, shear resistant check, and bearing resistant check as well, right? If you had a warning detailing red cross, you will see it in this tab, and then the detailing check will be at the end of this report. In this case, we don't have it, but like in the example where we had some warnings, what you need to do is go into the element that has this detailing issue, and then you scroll down till the end of that report, right? So once you identify what is making them to fail, which is the utilization in shear, then you can decide how to fix this connection, right? But it's a combination of looking at the deformed shape and then looking at the numerical results, right? And then from there, you can start deciding what to do with this connection. In this case, we can try to either add another bolt or increase the size of the bolt so we have more shear capacity, right? I'm going to do both things. So adding another bolt here, I need to increase the length of this plate. And then I'm going to change the bolt size too. But I'll do it also for the other operations. And then I can recalculate, and this is basically the design process. You review the results, then you come back to the design tab, do the changes, and then recalculate, right? Again, I recommend doing this check for all the connections that you have in your different files. Now everything is in green. We can go back to the check tab and then review the bolts again, and then review the deformed shape to see if that makes sense. Finally, after you finish the design of all the connections in your file, then you can come into the report tab and start generating all your deliverables. So I showed you previously how to create a brief report, but now you can see that I am under the detailed report that can be customized from this area. You can select what to include in this report using these buttons. You can also look at all the project items that will be included in this report. This is because I selected all the items in this file. You also have the option to select some of them, so that will be this option here. We have other type of reports under the report type area. And then another type of deliverables that you can create is DXF drawings. DXF is an open CAD file that can be opened in any CAD application, right? And then the other option that we have here is to create an IFC file. This IFC file will be available to be opened in BIM applications like Revit, Tekla, and so on. Finally, here we have this option to share a project. This button will lead us to our online viewer. Once we hit share project, then we'll have the option to open this online viewer where you will see all your connections in this viewer, and then you can share this online viewer link to other people that doesn't have IDEA StatiCa license. They can create a basic account for free, and then they can look at your connections in this link, right? So it's really useful because they can rotate the model, click on the different elements of the connection. They can see more details of that plate, details about the members, and all the components of this connection. And again, this link can be included in the report, so that will be part of your deliverables. The calculation package is as important as the connection design itself, right? So with IDEA StatiCa, you can create this calculation package, including a brief report as we saw it during the demonstration. We can also generate this detailed report from that file containing 10 connections. In this detailed report, you can include pictures of the connection, the view of the stresses on the entire model, drawings. You can also add the tables where the bolts and welds results are included. So everything is going to be on that report. And this comprehensive report can be generated with just one click for 10 connections, right? Also, you saw that we can deliver this link, and then whoever is reviewing this connection or these connections, they can come to this link, they can click on it, and then they'll have access to the 3D model. They'll be able to rotate the model, see it in detail, zoom in, zoom out, and then see more details about all the components in that connection. They can also download other files from the viewer, so that is nice to have, and that is a nice deliverable for the reviewer. And then you can also generate drawings from IDEA StatiCa, and finally an IFC file. This is an example of one of the IFC files that I generate, and then I open it in Revit. So again, super useful information to whoever is reviewing these connections, more than just looking at calculations, formulas, and tables with numbers, right?
Awesome.
Alrighty.
On a typical project, how many similar or repeated steel connections do you design? Is it 1 to 10, 10 to 25, 25 to 50, or 50 plus? So almost a tie. Around 80% of you are using repeated steel connections for, or I guess it happens less than 25 times on a given project. So I guess smaller size projects, but even for those, even 10 to 25 connections could be something that would take hours to redo one by one. So these standard connections could definitely be useful for even the smaller projects. But interesting to see that some of you do have very large projects. Guessing these are the data center ones that you will definitely benefit from using these time efficient tools. Excellent, thank you. So thank you so much for joining us today. If today's examples sparked ideas, or if you actually see opportunities to improve your own workflows or highlight the project that you're working on, we would love to continue the conversation. That could include case studies. If there's any project that you have worked on that you would like us to showcase and share with our users on LinkedIn and on our website, definitely feel free to reach out to us. You can get in touch through email or connect with us on LinkedIn. And if you're interested in the trial, you can try some of the features that you saw today using that 2 weeks free trial. In February, to get to the next slide. In February, we only have one in-person event. It's the SEF New York conference on February 12th. That will be our colleague Catherine Quick, who recently joined IDEA StatiCa, that will be attending. If some of you are in the area, please do stop by our booth there. And our next webinar will be on the 25th of February, and it will be about scaling connection design for commercial and high-rise buildings. And we will also talk about the use of checkbots and RAM structural system. We'll now jump into the Q&A section. We did have a few questions there. Let's see. The first question I had was, can you change the slope of the beam? So that was, John, actually, if you can go back to any of the first slides that you had showing some of the IDEA StatiCa connections, whether you could change the slopes of, let's say, that beam or this one. Yes, that's fully customizable. Any kind of slope or even tilt can be modeled in IDEA StatiCa. Can post-installed anchors be used for a column base plate connection? And how is post-installed anchors specified in the base plate connection design? Do you want to take this one, Johan?
Yes, definitely. So I'll just quickly show some of the connections. And just to finalize the previous question about skewed angles or pitch angles for beams or columns, they're all readily available. Whenever you click on your member, on the right-hand side, you have the data window. And from here, as you can see, you have the different angles, beta, your pitch and your alpha for rotation. So we were to do a 30-degree inclination, you can always do that. The plate adjusts itself, and if you need to make adjustments, you can always do that. Now we go ahead and take a look at one of our base plate connections. Let's say we choose connection 10. Whenever you're working with base plate connections, one of the most common operations that you will use will be called base plate operations. Its name gives it away, but just good to put it out there. And so once you select it on the right-hand side again, you have that data window. And if you go to your anchors, this is where you have the option of choosing cast in place or post-install anchors. This is a new feature that we've added. And for post-install, you have the threaded rod and you can define some of the parameters. One thing here is if you do have post-install anchors and you're looking to check that bond strength of your adhesive anchor, what you can do is one of the integrations that Jan described earlier in the introduction, and that is integrating connection with Detail 3D. That way you can check the steel components here, and then if you want to assess the bond strength of that post-install anchor, you can export your results into Detail 3D, add the reinforcement in your concrete, and then from there run the analysis and prove your post-install anchor works. From there, we'll be able to check the bond strength of that post-install anchor and provide you a pass or fail check.
Awesome. All right, next question. Does IDEA StatiCa support continuous beam over column connections with braces that also frame into the nose? So all the connections that we were showing here were showing a continuous column, but yes, obviously you can make any modifications that you want for a beam to column connection. For example, if the beam is running over the column, that is definitely doable. It's just a couple settings to modify, and you can add braces and horizontal braces or vertical. That's not going to be a problem. Yes.
This is where you would be able to change the geometrical type from an ended to a continuous, and from there continue your work. Alrighty, one of the questions that I saw is, can the loads be imported from another software like RAMP? So to quickly answer that, and short answer, that is yes. I will highly recommend everyone who's interested in importing your loads to go to our website and head on to the BIM integrations. From here, you will be able to see all the different global analysis software that we're able to integrate for you to bring in all that good information into the software. Not only will you be able to bring in the load combinations, but you can also bring the geometry, the entire structure, materials, and cross sections. So all you have to focus in is just modeling the connections. And one quick thing to mention is we not only work with global analysis software. If you have any detailing software, we're also able to integrate with those in case you want to bring in those detailed connections and assess them in IDEA StatiCa.
That's true. Another question was about the batch change feature. For example, you start a project using 3/4-inch bolts for several operations, and you would like to change those to 1-inch bolts. You can do that by holding your control key and clicking on several operations in IDEA StatiCa, and that will actually allow you to model or make modifications on several separate operations. So let's see which ones could work out. You didn't have them there. So yes, just hold the control key and you'll be able to make such modifications.
All right, and can we model slip critical bolts? That is definitely a yes. Whenever we are working with bolted connections, under the bolt section, the last option, you can choose either bearing or friction, which will be the slip critical option.
Finally, before wrapping up, a few questions about the recording and the PDHs. So the recording will be posted on our website tomorrow. It should be in the same link as the one where you registered for this webinar. And the PDHs, if I'm not mistaken, are sent directly by GoToWebinar within a week of the webinar. So everyone will receive a PDH by email within a week. Is there any other question that you saw, John, that you'd like to answer?
Let's see. No, I just saw questions about connection library, whether there's limits onto the amount of connections that you can have. The answer is no. You can add as many. You can populate your library as much as you like. Again, Andrea covered how you can organize them by either moment, share, pinned, or even adding the different naming conventions. That's one way that you can organize them, and you can add on onto your library. But if there's any questions that we might have missed here in today's webinar, we'll definitely make sure to follow up with you after this is over.
Yes, I think a lot of questions just came in. We'll probably have to answer those by email. All right, I think that wraps it up. Thank you so much, everyone, for having joined today's webinar. And if there are any questions, feel free to get in touch with us. For those of you who have questions that are left unanswered, we will be getting back to you as soon as possible. Thank you.
Thanks, everyone. Have a great day.